Hello, everyone. My name is Karen Laird, and I'm the editor of Sustainable Plastics. Welcome to this webinar featuring Pall Corporation, a leading provider of filtration, separation, and purification solutions. The technologies the company has developed support the further advancement of, among other things, pyrolysis-based chemical recycling. And today we have three experts from Pall who will discuss these technologies and explain how they work and why they are necessary. They will also give us real-world examples of how pyrolysis is transforming complex, hard-to-recycle plastics into valuable, high-quality recyclables. Our speakers today are Serhat Ozeron, Daniel Jensch, and Mohsen Salahabadi. They will share practical insights and data from real applications, and afterwards we'll be happy to answer any questions you may have. If you'd like to submit any questions, please drop them into the chat and we'll address these in the order asked. And please be assured that if we run out of time, we'll get the answers back to you in due course after the live stream. Now, that's enough from me. It's time to hear from our experts at Pall. The session will be kicked off by Serhat. Serhat, the floor is yours.
Thank you, Karen. Hello, everyone, and welcome to our webinar. In today's session, together with my colleagues, Mohsen and Daniel, we will actually walk you through our journey with pyrolysis oil. And on the next slide, I would like to share you the agenda and to take a shot on the, let's say, type of analytical methodologies that we are using for characterizing the contamination in pyrolysis oil. And of course, with the variety of the feedstock compositions and the impurity profiles, how we basically created a comprehensive library and how we also found tailored filtration and separation solutions. And of course, all based on the real world examples by sharing you the case studies. As Karen mentioned, at the end of the webinar, we will have the Q&A sessions. Please feel free to put your questions into our chat box, and we'll be happy to answer all these questions to you. On the next slide, I would like to mention about our company, Pall. It's been established in 1946. We are actually about 5,000 employees globally, and Pall is actually known as delivering actually the technical solutions and to overcome the challenges in filtration and separation. And the thing is, it's with all the knowledge that we have from our expertise in the filtration and separation technologies, solving the different challenges in these in different industries. So we are serving from aerospace industry to food and beverage industry, and we are part of the Energy Plus business, serving the refinery or petrochemical polymer plants, and of course also energy transition markets. On the next slide, I would like to give you an overview. In terms of energy transition or decarbonization, this is not new to Pall. We've been working on this industry actually since decades. But in the last 6-7 years, we put a special focus on these topics, basically to solve solutions and running our innovation engine, working with our research and development department, basically to find solutions to overcome the challenges in, for instance, carbon capture, utilization and storage, hydrogen, biofuels, or battery, and of course, plastic recycling. And we are also happy to answer any questions in case if you need support in these different types of decarbonization solutions besides pyrolysis oil, we will be happy to help you. And on the next slide, this is pretty much the overall picture. It's like a high-level picture in recycling and how Pall can support. So you can see here to produce, all the way from hydrocarbons to monomers to polymers and the plastics, and plastics being ending up, let's say, in waste. There are different types of recycling routes that they can basically use for recycling plastics. Pall's focus so far was more on the advanced recycling routes, such as chemical recycling, including pyrolysis and gasification, depolymerization, solvent-based recycling. This has been our focus, and we believe that there are different areas that we can help you with besides the pyrolysis, which will be our topic. And to give you how we do that, on the next slide, our technical approach, and of course, how we provide our products or solutions and services, it pretty much starts, if I will give you, every pyrolysis oil project will start with lab services. So basically, this is our entry point, and where we do the, let's say, our process and concept development to narrow down the types of filtration and separation techniques, what kind of filters or coalescers or membranes will be used. That is basically being enabled through lab scale testing. And then you continue the upscaling towards pilot or demo scale, where we are actually thinking of more detailed engineering and the project execution. And if the project will be commercialized, of course, providing that in the commercial scale. This is pretty much the part that I would like to share with you today. And with that, I will pass to my colleague, Daniel. Thank you.
Thank you, Gerhard, for introducing our global service offerings. Indeed, we are really proud to be recognized as a trusted partner for our scientific services. This trust actually gave us the opportunity to collect data from more than 500 individual analyses from more than 50 lab and field projects within the field of advanced recycling. So our support typically starts with a pre-assessment where we look into the contamination and the physical properties of fluids and the contamination loads. From there, we actually identify the right media, which we then test in our application validation. Depending on the scope and the requested targets of fluid final specifications, we are testing liquid-liquid separation with our coalescer filters or fluid filterability using various media types. These studies are typically performed on a lab scale at one of our centers of excellence within Pall, or on-site using either our mobile filters or coalescers as a rental opportunity, or the other alternatives running pilot studies using pilot units, and these are supervised by our field scientists. So the application validation studies are typically then followed by a post-assessment on the treated fluid on the contamination levels, proving the achieved downstream quality. As a first example, I want to introduce our coalescer technology to you on the next slide. Next slide. So within the plastic waste pyrolysis process, there are typically multiple sources of water that can entrain into the pyrolysis oil. Typically, sources are moisture in the plastic feed, processed water, which can be generated from oxygen-rich or containing polymers during the pyrolysis itself, or added water for py oil treatment. Under lab conditions, we have tested pyrolysis oils with up to 15% of aqueous phase in the py oil. However, that wouldn't be recommended. You can imagine that multiple factors impact the collation's efficiency and the removal of the so-called dispersed phase, like interfacial tension, density differences, the pH value of the aqueous phase, and the viscosity of the py oil. As these are unique to any py oil which we have tested, bench tests are typically performed to determine the separation feasibility and identify also the range of flow rates which will lead to a successful separation. Typically, the target is to remove free water from the py oil and bring it down to the total water content, which is really close to the solubility limit of water in the py oil. And we determine that with typically with the Carl-Fisher titration method. The interfacial tension is another really critical factor for the success of liquid-liquid separation. And the values we have typically observed in the lab are in the range of less than 1 dyne per centimeter up to 40 dyne per centimeter. And we could actually successfully demonstrate a solution for any of these challenging applications. And typically, the higher the interfacial tension, the easier it is to separate liquid-liquid, so separate water from py oil. as the coalescer can act as a filter itself, it's really important to protect the coalescer by a pre-filtration, which leads me to the next slide, where I will detail the removal of solids and semi-solids. So besides the particle size distribution analysis, which we typically perform on the contaminants, the gravimetric quantification of contaminations is the most critical measure to select the best filtration setup. We differentiate between total suspended material, which is composed of total suspended solids plus semi-solids. And those are retained typically on a test membrane with a defined porosity. The TSM values are strongly temperature dependent, as they contain gums, tars, and waxes, for example, which exhibit a certain melting temperature. So as the semi-solids could cause very quick fouling on the filter on one hand, and on the other hand could be regarded as a part of the value stream, so they actually do not cause downstream problems, it is crucial to select the right filtration temperature. As example, we could significantly reduce the TSM by increasing the filtration temperature from 45 to 80 degrees C by 94%, which gave a relief to the filter and also increased the yield of the downstream pie oil. So typically the harmful effects on the downstream process are created by solids, undissolved solids. And these are quantified by a sequence, so applying a sequence of solvent rinsing steps to the TSM membrane. The TSM and TSS method is also helping us to understand and quantify the evolution of contaminations during the storage or transportation of pie oils. So it's quite crucial not only to select the right membrane technology and membrane rating, but also helping the customer understanding the root cause of contaminations during the process. And I will show you the selection or the way of selecting different media on the next slide. So typically, we distinguish between two different filter types. So membrane filters, which exhibit a surface filtration mechanism. So the particles, the solids are retained on the surface of the membrane, and depth filtration, which in addition can utilize the void volume of the filter media. On the next slide, you will find a summary of the results of multiple media tested during validation studies. So for this data analysis, we have clustered pie oils according to the initial TSM values and TSS values, and the filtration efficiency was calculated by the difference between the initial TSS values and the downstream filtrate values. So by applying different media, so depth and membrane, and you can see actually the filter rating on the bottom line, we were able to remove up to 99% of the TSS, and if requested, up to 80% of the TSM. It turned out that depth filter media are much more robust against variations in the pie oil composition and give a much higher filter lifetime compared to membranes. It's not surprising that finer filter media are more efficient to reduce the total suspended solids for finer particles below 5 micron. Coarse media, they give typically a better lifetime, however, come with a lower removal efficiency. So we identified a medium-rated depth media, which can be applied to first reduce the contamination levels to meet the downstream requirements, and at the same time showing a balanced filter lifetime. If the initial TSM values are too challenging, also a multi-stage filtration utilizing a coarse followed by a fine filtration can be considered and are recommended. So, but how does actually how does this actually impact the downstream quality? And this is actually what we have studied together with the Ghent University, and I will show you a summary on the next slide. So from the Ghent University has internally produced a pyrolysis oil for academic research and has shared this Pi oil with Pall Corporation. We have performed with our defined filter media filtration tests and also did the TSS particle size distribution plus a SEM EDX analysis on the filtered and unfiltered pyrolysis oil. After understanding the filtration mechanism and seeing the results of the contamination removal, we have shared back the filtered sample to the Ghent University, and they have tested actually the impact on coke formation in their cracking unit, so technical center cracking unit. Plus, they have in detail studied the reduction in metal content. So what we have demonstrated is that we could remove more than 97% of solids, which led to an up to 80% metal removal, which is a coke initiator. Compared to pure naphtha, they couldn't see any effect on the cracking yield when they used the one-to-one mixture of naphtha and the purified pyrolysis oil, and no hydrocarbons composition modification. However, a drastic reduction of coke formation in the furnace could be observed when compared to an unfiltered blend of naphtha. So if you're interested in this study, it's available as a summary from our webpage. And with this, actually, I want to hand over to Mohsen to give you more insights on how filtration can improve the coking behavior in crackers.
Hello. And before we go, there's a poll question. Please, if you can take a look at the poll question and answer.
Hello, everyone. It's been a pleasure for me to be here and to discuss with everybody about the supports as a filtration and separation company that we are bringing into the waste plastic recycling initiative through the thermoconversion, and aligned with my colleague Daniel presented the validation in the lab based on the work that we have done with Ghent University. We requested to duplicate it in the field in terms of how the filtration and separation can bring more added values in terms of the chemical and physical compatibility between the pyrolysis oil and the naphtha feed to the specific steam cracker. In that experiment in the field, we prepared a setup of the filtration unit as a demo on site, and we tried to duplicate what we achieved in the lab and in the field to reassure that the pyrolysis oil will remain cleaned before blending, with the naphtha feed. And based on this experiment, we used the depth media that has been tested and validated in the lab to make sure that the pyrolysis oil will remain clean before blending with the naphtha, just in order to control the fouling and the coking in that particular steam cracker furnace. And based on that, particulate filtration was in place. Operator were able to measure some parameters around their operation, particularly on their cracker feed, which nearly around the fouling in the convection section, as well as the coking rate and the decoking rate on that particular furnace. And this experiment proved that more than 90% of the solids and semi-solids have been removed by the depth filtration. In average, for the suspended matter, we were able to adjust the 50% reduction as per requirement by the operator. And overall, the pyrolysis oil met the cleanness specification to be mixed and blended with the naphtha before going to the cracker furnace. And this experiment and this field operation has been ongoing for a couple of years. But right now, I think more than 2 years that this filtration is in operation, in service, just to make sure that this kind of practice will be in place. In the next few slides, I would like to share more insights about what kind of added values that Pall can bring as a filtration and separation technology and know-how developer to the pyrolysis oil producers, know-how developers, as well as integration with the off-takers and operators. At Pall, we understand the cleanness of the pyrolysis oil, which is being derived by the thermal conversion process, is essential for the downstream process and the market acceptance in terms of the physical and contamination content, to make sure that this pyrolysis oil, which is being produced, will be completely integrated with the downstream processes. In order to achieve this objective and the goals, we try to interlink the cleanness of the pyrolysis oil to the downstream, simply starting by cleanness of the pyrolysis oil, and the cleanness means whatever included as a physical contamination, including solids, semi-solids, tars, as well as the liquid contaminations that appeared most of the time as a water, emulsified water, dispersed water, and another part of the liquid contamination could be related to any kind of upstream liquid extractions that sometimes is being utilized, like solvent wash, to adjust the chemistry of the pyrolysis oil, that this solvent appeared in the pyrolysis oil sometimes as a dispersed phase that needs to be separated. Therefore, one of the approach, in addition to the contamination control, is helping to protect the critical assets, because contaminations can cause the fouling, corrosion, and sometimes the catalyst poisoning if there are some fuel upgrades downstream. And the filtration system acts as a kind of protective barrier to protect these critical assets, like heat exchangers, heat exchangers, and sometimes the catalyst if it comes to the hydrotreating unit. And definitely this conversation translates into the higher plant reliability, as well as the lower maintenance cost in the downstream. In addition to that, unit operation cost reduction will be another added values by that directly linked to the improving the feedstock quality and reducing the fouling tendency of the pyrolysis oil, by considering the fact that pyrolysis oil could be very dynamic fluid. The contamination content could be very vast, and sometimes it will be very challenging to get it treated. That's why always the unit operation will be a big concern that is directly linked to the cleaner pyrolysis oil for the downstream processes, and the filtration and separation indeed play a significant role, and we understood that. Optimization on the maintenance, will be another added value, that the system, the filtration and effective filtration design definitely will help to ease off maintenance for the downstream processes and equipment, as well as meeting this HSE requirements by removing the hazardous impurities that help the facility to meet this kind of requirements, that all the processing plants, they have a concern around. Another initiative and added values that we are working towards on our carbon footprint, of the pyrolysis oil processes, which is linked to the integrators as well as to the downstream processes, simply by helping to reduce the CO2. Because the system is a fouling system. The pyrolysis oil or thermal conversion is a fouling process, and less contaminations will be circulating within the process that called as a formation solids. Definitely, it will help, to have an energy balance within the process and the downstream, and energy balance immediately linked to the CO2 footprint. Ultimately, within this journey, within Pall, we are trying to help the industry to implement this kind of approach and solutions faster, smarter, as well as within the cost. To accelerate this kind of initiative, we are trying to offer the kind of modular standard design for filtration and separation that help as a kind of plug and play solution by pursuing the three main objectives in general. The basic one is minimizing the engineering and installation costs as far as filtration and separation equipments are concerned. Definitely to help to reduce the commissioning time, as well as allowing to the scalable deployment across the multiple sites when it comes to the integration to the co-processing, as well as to any brand new pyrolysis oil plant. These are the kind of engineering practices that we are implementing in-house to make sure that the solution will be the ideal solution for both greenfield projects as well as the co-processing integration, to help the industry and market to lower the total cost of the ownership. In the next two slides, I would like to highlight the major filtration and separation applications that it will be categorized into two parts. One is for the pyrolysis oil production processes and a plant or know-how, and the second one will be the integration when the pyrolysis oil producers, they need to integrate their process within the downstream. It could be refinery co-processing or maybe a petrochemical. In this slide and a snapshot, you can see the coded number of the applications that they are listed, that starts from the pyrolysis oil post hot gas filtration, that we are trying to develop and bring an avenue to this industry and this concept, enabling the pyrolysis gas to be filtered sooner and early advance enough to make sure the fouling behavior of the system will be controlled at the point of the pyrolysis gas production. This is one of the initiatives we have in the organization, and we are trying to develop and promote it. When it comes to the liquid side, definitely liquid pyrolysis oil needs to be filtered to remove the contaminations, as well as the water and solvent that they are coded by the 2A and 2B in this snapshot. If there are a gas production that this gas needs to be treated like off gases, or any kind of produced gas, it lands, to the gas sweetening, that the gas cleanness and the solvent cleanness will be always there. And the bottom side of the slide shows any kind of fuel upgrade or pyrolysis or hydrocarbon fuel upgrades when it comes to some other aspects of the cleanness, for example, like mercury removal, silica removal, chlorine adjustment, that these kind of processes, they need to meet a certain cleanness of the pyrolysis oil before putting in the catalyst or adsorbent to meet those kind of objectives. And overall, filtration and separation helps to make those processes more efficient and then within the less cost. And lastly, when it comes to the integration, on the next slide, I'm gonna present a very similar approach but probably in the different aspects when it comes to the pyrolysis oil upgrade processes. That when it comes to the, for example, hydrotreater process, the pyrolysis oil needs to be clean and dry. When it comes to the adsorbent process for silica or mercury removal, exactly the same drivers. And sometimes some designers, they are trying to implement the liquid extraction to get the chemistry of the pyrolysis oil adjusted when it goes to the fuel upgrade, and carried over, of the solvent, carried over, sometimes, the water could be problematic, for the downstream, and that's why this coalescers and separation will be in place. And in this, and then as you can see, the integration between the end user as well as, the pyrolysis oil productions, they could be very comprehensive in terms of, the need for cleanness, of the pyrolysis oil, especially when it comes to the petrochemical or steam cracker feed blend that the potential filtration applications are listed here. I think that's my last slide, and by reaching to this point, I will hand it over to Karen to resume, and I will remain for any questions that it will be addressed by Karen towards the team. Thank you.
Thank you, Mohsen. And actually, thank you to all our speakers for their very insightful presentations. Now we've got time to take a few questions, but before we do that, I'd first like to see the results of the polls. Would that be possible? Are they available? Okay. So it looks like we've got a tie for no and maybe in the future. Right. And the second one. Did we have the results for the second poll? We don't. Okay. Let's take a few questions now, because I see we've got a lot. Let me see. The first one here is let's go back to the poll. Are you attending the webinar? Okay. I hope everybody's had enough time to decide their answer. Let's go to the first question now. From Shreyans Jain. Post-filtration, can the plastic pyrolysis oil have a quality equivalent to petrol and diesel? Is the question. Daniel, would you like to take that one?
I can take that one. So typically, even so, filtration is really good in removing particulate contaminations. There, in particular, in plastic waste derived pyrolysis oil, contaminations which are actually dissolved, like organic halides, like silanes or siloxanes, and it's really difficult to remove those with a pure particle filtration. So the answer is, in fact, no, it can't be at that stage without having any other upgrading process in place. However, what we have learned in the studies together with the Ghent University and the group of Kevin is that we can significantly reduce metal, and that is actually impacting the cracking process positively. I hope that answers your question.
Okay, thank you for that answer. And I have another question. Do you have technology that can remove ash from pyrolysis gas before it's condensed? I think that would also be Daniel, perhaps?
So we do, in fact, have hot gas filtration in place, but in fact, the applicability would also depend on the process conditions, whether we can expect condensation at the filter, which is definitely a no. And also the particle size distribution of the dust, so the coke formed during in the process, which is also determining whether hot gas filtration is applicable or not. But typically the answer is yes.
Okay. Okay, I have one from Rob de Ruiter. To avoid double bonds in the pie oil, cracker feed, hydrotreatment seems always to be necessary. Did you study the benefits of hydrotreated pie oil? No.
If I can take the question, Karen.
Thank you, Mohsen.
No problem. Definitely the question, is very valid, is a very good question. In order, to adjust the pyrolysis oil chemistry as a part of, the fuel upgrade, the hydroprocessing, is one of the options, to be considered. The question to the double bond formation in the pyrolysis oil, it is a kind of inevitable because definitely this is related, to the nature, of the process, which is the thermal conversion, that on the unsaturated olefins and diolefins, will be produced, and that's why, the hydroprocessing, needs to be in place. But as far as filtration and separation is concerned, the feed filtration to the hydrotreater as a guard bed, for the hydroprocessing, if we go back, to the refinery legacy knowledge, it has been, in the design and the license, for decades. And the same conversation, will be applicable here, that in order, to utilize the hydrotreater, in order to meet those requirements, feed cleanness to the hydrotreater reactor, will be always a concern and question, that we are helping to get this integration in place to make sure, the pyrolysis oil will be dry and clean to the level that the hydrotreater catalyst needs in order, to do this the double bond saturation within the process. And we are we as an organization, have been working in the conventional or legacy refineries for decades, and now we are working as well, to bring those knowledge, fine tune it, in order, to get, the pyrolysis oil cleaned enough, when it goes, to the fuel upgrade, including hydroprocess.
Okay, thank you. I have another question. Can you give data of amount of substances, contaminants before and after filtration? No.
Yeah, so I can take this one. I mean, there's a good reason why we didn't show any data on that, because it's data which we created internally. However, we have a good set of data published together with the Ghent University, and this is published data. We are also creating a white paper, which gives at least an overview of the ranges we are treating, because as you can imagine, all pyrolysis oils are very individual, depending on the production process, depending on the feedstocks used in the process, and we want to propose a filtration solution which actually meets the feed, so the pyrolysis oil, but also the specific quality requirements at the end. So as you can imagine, there's a wide range, and we are actually looking more into the range in individual tests rather than giving a broad number with regards of the contamination levels.
Okay. And here's a question about, well, is there any restriction on the solids generated during the pyrolysis process in the filters? Type of solid, is it as polymer material or other chemical solids? So
I can take this question and then try to answer, briefly. The solid formation and the solid generation, or I would say in general, the contamination formation in the pyrolysis oil, again, it is inevitable conditions. It means contamination will be produced, within the process of the thermoconversion, because this is the nature of the process. The system, is the Fowling system, or the process, because we are converting, the waste plastic chips, or the polymers to the mixed, of the hot gas vapor, and then try, to condense and then cool it down to the liquid hydrocarbons. Within that journey, definitely the contaminations, will be produced that normally we call it as a formation contaminations. But the question is how it can be handled, how it can be minimized within the process of the pyrolysis oil, and how it can be handled, at the point of the liquid pyrolysis hydrocarbon will be appeared. The first part, definitely, the pyrolysis oil know-how developers, ultimately, they are looking at, their process, to minimize the formation rate, of this contamination, because it has a direct impact, on the plant and on their operation and process productivity and the reliability. This is one part, of the story is being handled, by the pyrolysis oil know-how developer. But in the other hand, we tried, to complement, this work by bringing this filtration and separation know-how to get, the pyrolysis oil cleaned to meet the specification, cleanness specification by the off-takers, could be refineries, could be petrochemicals, as well as to adjust, this contamination content to the level that the market and industry wants to take it, for a different purpose. This will be, to summarize, this will be a kind of collaborative work, between companies like Pall, and the know-how developer, to have this balance in place to make sure, the pyrolysis hydrocarbon, when it's being produced, it will be cleaned enough.
Okay, that's fair. Okay. And what is the size range that the filters can handle? Maybe Mohsen again?
Yes, I can take it. I was waiting for Daniel, but I will take the question too as well. The size of the filter. There are two aspects, on this question, which is a great question, by the way. The one is the average of the particulate or the particles size distribution in the pyrolysis oil that this drive, the degree of the filtration in general. And the second point is the available media, means, the filtration technology or the media or membrane, that can respond, to that kind of requirement. From that part, which is the available technology, filtration technology, the answer, is very much yes. Means, the filtration can be covered, for example, from the 500 micron down to the 1 micron. To the size, of the near bacteria, in that range, when I am talking about, the 1 micron. The filtration technology is available, in the market, and then we have it in Pall as well, to offer. But this needs to be matched and tuned up and aligned based on, the actual requirement, for pyrolysis oil cleanness, by considering the average particulate size distribution to make sure, for example, is it the X micron rating is being required to get the pyrolysis oil cleaned, or Y micron requirement. That's why we tried, to have that kind of work in place, to have that kind of mapping data to understand what would be the actual needs for filtration in order, to get, the pyrolysis oil cleaned enough, either, by X micron rating or Y micron rating.
Thank you. I hope that's clear. Here's a question. Is this upgrade process only about removing solid contamination?
I take that again. No. When it comes to the pyrolysis oil, we are talking about the chemical composition adjustment, as well as the physical contamination removal or adjustment. When it comes to the pyrolysis oil, for example, the oxygen content, nitrogen content, sometimes the unsaturated content, aromatic content, which is related to the chemistry of the pyrolysis oil, are the big drivers for the off-takers. In addition to that, the contamination as well will be another concern. Therefore, the chemistry adjustment of the pyrolysis oil needs to have the process like hydrotreater, or something similar, to adjust the chemistry. And in order, to make sure, that the fuel upgrade, will be in place, cleanness, of the pyrolysis oil, is crucial, to make sure, that physical contamination will be removed in advance before letting the fuel upgrade process to adjust the chemistry, of the pyrolysis oil, and then before going, to the market, or the downstream, for any use or any purpose. That's why this journey is a combination, of the two main actions. One is physical contamination adjustment and chemical composition adjustment, but in the two different aspects, of the process, that at the end of the journey, they are completely complementing each other.
Okay. Right. Now I've got a slightly longer question. It's from Matthew, who says, "Thank you for such an interesting presentation. Do you use two-dimensional gas chromatography to assess composition of pyrolysis oil? And are there significant differences on oil composition by using different plastic feedstocks? For example, polyethylene versus polypropylene?"
So maybe I can take that question. So the simple answer is no. And I can tell you the reason behind that. We are actually more interested in particulate removal and not so much in the composition of the liquid or in the composition of the gas. When you're interested in such topics, I can definitely recommend literature published by Kevin van Game's group from the Ghent University. They have a great group using GC cross GC technologies to really understand and identify the different composition of different feedstocks or created from different feedstocks. But this is in fact not the main focus for us as a filtration company.
Okay. Thank you. And what is Pall's process for treating the solids, which are usually chars?
I take that question. That chars is one of the when we look at the contamination profile in the pyrolysis oil, chars is one of them, and depends on the feedstock, depends on the process or pyrolysis or thermal conversion process. The ratio and the balance between the chars and other contamination could be changed or could be varied. Sometimes are higher, sometimes are lower. Therefore, when it comes to the filtration and separation, means the physical contamination removal from the pyrolysis oil, definitely chars is one of them that needs to be removed by the physical barrier, which is filter, and this is exactly that what we are trying to do, and then we are doing it the removing the chars. And the answer is yes, chars will be removed, by the filter, and efficient filtration to the degree, to the level that the pyrolysis oil needs to be reached in terms of, the char content. There is another aspect, to that question that depends on the thermal conversion process upstream. Sometimes the ratio of the chars, is higher, especially when it linked, to the suspended matter like asphaltins, or some kind of soft solids in. And in order, to handle the char, sometimes, the suspended matter needs to be handled, along with the chars at the same time. That in that kind of concept, the ratio and the concentration is higher than maybe the range of the filtration as a polishing stage. That's why sometimes a combination of the pre-treatment and filtration needs to be considered in order to handle the chars and the oil coated chars before reaching to the filter to adjust the cleanness for the downstream. That's why understanding the char's content, understanding the char's behavior in the pyrolysis oil is crucial to define the treatment strategy and scenario.
Okay, thank you. And how about molecular contaminations like SI or nitrogen?
That's a good and tricky question, to be honest. I can take that. So what we have seen in our studies is that if the nitrogen is part of nitrogenates, so like asphaltenes, and it tends to precipitate, it can be removed through filtration. The same is true for silicon. However, if we are talking about silicon or silanes or siloxanes, which are typically dissolved, that's a different story. Our media typically shows some adsorptive capabilities, and we are actually currently studying new R&D media on that topics. But this is actually I cannot share any more details with you. But in fact, we have identified those contaminations as key contaminants, and also working on solutions to remove that, which is also true for chlorine removal. However, at the moment, we don't have the solution to offer to customers, but we have the capability to investigate and test new media with your pyrolysis oil and identify a potential solution.
All right. Okay. And does Pall have solutions for high viscosity polymer melt filtration to remove particulates upstream of the conversion process?
I can take that question. Yes, we do have a complete range of melt filtration systems, basically including the filtering media. As Daniel explained about the surface or depth filters, we are producing different types of metallic media and also metallic elements, filter discs or pleated candles, which are put into the let's say inline type of systems that can be basically used as a pre-treatment of this high viscosity polymer melt filters. As polymer melt filter.
Okay. If you hydrotreat the pyrolysis oil, is particulate filtration still beneficial? Is the next question.
I take it, Karen, is a good question. And filtration and the hydrotreating process, they are totally different topics. It means filtration is not a replacement, for hydroprocessing, or the fuel upgrade. Hydrotreating, or the fuel upgrade, they are doing, their duty, to adjust, the chemistry, of the pyrolysis oil. And filtration is complementing, the hydroprocessing simply by removing, the physical contamination and let the hydroprocessing, doing their job, to adjust, the oxygen, nitrogen, for example, and the chemical composition. It means that we are not in this presentation and in this conversation, we are not talking about replacing the filtration with the hydroprocessing or the fuel upgrade. The message here is complementing each other, and this complementing is not the idea, is not a kind of ambitious idea. If we look at the hydroprocessing in the refinery or legacy refineries from the naphtha, kerosene or the gas oil, definitely the filtration or the guard bed or the reactor guard bed protection is one of the key equipment up front of the catalyst of the hydrotreater catalyst in order to let the process do the job. And that's why here we are talking about the complementing this kind of process by the physical contamination removal before going to the hydrotreater to adjust the chemistry of the pyrolysis oil before going to the end user.
All right, thank you. And is it possible to process multi-layer plastic waste with pyrolysis? Who's?
Maybe just a quick comment on this one. Basically, in terms of feedstock, there are a variety of feedstocks, right? So we actually went through this presentation, and when it comes to this type of multi-layer plastic waste, such as like advanced packaging films and so on, there will be different types of contamination. This again, for our knowledge, it will be again the start in lab, and I believe that Daniel may also include his comments here. But of course, pyrolysis can be a way, but we can also consider other recycling routes, such as solvent-based recycling, for instance, if you are targeting certain polymer type and just to basically recycle that. I don't know, Danny, you want to add something?
So fully agree with your comments. So since we are not a pyrolysis plant operator, however, working with a lot of different technology providers or technologies in the market, the answer is yes. There are some companies which are using a technology which is more sensitive to multi-layer packages, so heteroatom containing oxygen barrier layers and so on. However, there are also very robust technologies in the market, and as a matter of fact, we can support to purify the downstream product and even do the upgrade. However, the feasibility of applying multi-layer packages as a feedstock is more in the hands of the pyrolysis reactor operators rather than in our hand as a downstream upgrading company using filtration and separation technologies. So hope that can answer that question a bit more clear.
Yes, thank you for clarifying that. I have a question. What kind of plastics have you assessed when running your filter tests? Polyolefins, rubber, ABS, fluorine containing plastics, etc. All of the above.
I would like to share some inputs around this question. Within our work in Pall Corporation on the circular economy, we are deploying this kind of expertise, to handle the different type, of the plastic feedstock. It's not only, the plastic feedstock, it will be, to the rubber recycling, for example, when it comes to, to the waste tire recycling, for example, that becomes, it is in very early development, but, becomes more visible, in the market, that the waste tire recycling as well, is one of the initiative, that the market, is looking at, and we are deploying, the filtration and separation expertise, in a way that we presented, in this slide. The answer is yes. It means, our work, appeared, in the wide variety of the plastic feedstock, from the basic polyolefins to the some more engineered polymers like ABS, some halogenated, for example, the plastic like PVC, and including, the very complex polymers like rubber or tire recycling, that we are trying, to bring this kind of knowledge, enabling, the producers, to get the pyrolysis hydrocarbon cleaned, regardless what the feedstock, are being utilized as in pyrolysis process.
Thank you for that answer, Mohsen. And I'm going to have to wrap it up here because we have only around 1 minute left. So what I'd like to do is I'd like to repeat that if any additional questions for our speakers that we didn't get to during the session, they will be collected and passed on so that they can be answered afterwards. So no worries, there will be a follow-up. And now I'd like to say thank you to our speakers. I'd like to say thank you to our attendees, and goodbye.